Hi everybody, welcome to my Chem 120 lab walk portfolio presentation. Today we'll be talking about the chemistry of coffee. Let's get started. What is coffee? What do you think of when you hear coffee? Many people may think of the smell of the brew, some people may think of the police, some may think of waking up or caffeine. Although what you may think about coffee and its basic functions may be true, the chemistry of coffee goes far more in depth than one may think. Coffee is composed of many components that make up the composition of the coffee, and each of these can be altered very easily through the brew's manufacturing process. According to Australian Academy of Science, two of the biggest factors that affect the composition of coffee are the harvesting and roasting processes. To begin, coffee plants are harvested for the fruit called coffee cherries. These beans then undergo the process of fermentation in which the outer layer of the coffee cherries is either removed or dried off. Following this fermentation process, the roasting process then occurs. During this roasting process, there are chemical reactions that occur. The major ones are the Maillard reaction and caramelization. The Maillard reaction is a series of chemical reactions that I will get into in the following slide. But following the Maillard reaction is caramelization. This usually occurs at around 100 degrees Celsius, and this is responsible for the dark coloration of the coffee beans. The Maillard reaction. According to Barista Huddle, the Maillard reaction is a series of chemical reactions that occur in coffee beans when the roasting process begins. This usually occurs at around 140 degrees Celsius and higher. This reaction occurs between a reducing sugar and amino acid. A reducing sugar is any sugar that contains a free aldehyde group or ketone group. What makes these special is both of these groups contain an oxygen atom double bonded to the carbon chain, and this allows for a reaction with the amino acid. As for the amino acid, the structure has an amine group on one end and a carboxyl group on the other. The amine group is what is responsible for or being involved in this reaction. And to get more in depth with this, when the amino acid and the reducing sugar react together, this gives off a molecule of water. And this is because a nitrogen from the amine group bonds to the carbon chain of the reducing sugar, releasing a molecule of water. From this process, glycosylamine, which is unstable, is produced. And because it is unstable, it has to undergo another structural change called the Amador arrangement. And from this, it then undergoes one of three potential reaction paths. The first being it loses more water molecules to become more carbonyl type molecules. It can break down into short chain molecules, and the third way is that it can react again with more amino acids. The outcome results in products available to react with even more amino acids, and this usually forms melanoidins. According to Australian Academy of Science, coffee also has many key components that affect the characteristic of each brew. These components are alkaloids, volatile compounds, acids, and lipids. The alkaloids that are present in coffee are caffeine and trigonelline. These usually affect the bitterness of the brew because in the original form they have a very bitter flavor. Trigonelline usually decomposes though at 160 degrees Celsius, and this usually contributes to the aromatic compounds of the coffee during the roasting process. So when the beans are being roasted, the smell that comes from that is alkaloids' responsibility. Volatile compounds, these evaporate at room temperatures and are responsible for much of the coffee's aroma after the brewing process. So when the coffee is being brewed, volatile compounds are responsible for that. Acids, these help balance the sweetness and the bitterness of the brew. And finally, the component lipids usually contributes to the texture of the brew, so how thick or thin the coffee comes out. According to Coffee and Health, along with the components of coffee, there are also compounds present in the brew. These components are caffeine, antioxidants, diterpenes, and mycotoxins. Caffeine is the main alkaloid present, and in the previous slide we covered what an alkaloid was, or the alkaloids present at least. Antioxidants, the antioxidants such as chlorogenic acids and melanoidins are present, and these usually help deactivate oxidants and can have certain health benefits. Diterpenes, these are naturally found in the oil of coffee. Common diterpenes are cafestol and quail, and these can potentially help protect against some cancers. As for mycotoxins, potential mycotoxins commonly found in coffee are ochratoxin A, acrylamide, and furan. All of these have been found to have a potential health risk, but none have been found to have any carcinogens. What is an alkaloid? According to NCBI, an alkaloid is a compound that contains at least one nitrogen atom and has physiological effects on the human body. Some other examples of alkaloids are morphine, caffeine, and nicotine. And caffeine is the alkaloid present in coffee and can have physiological effects on the human body. in the corner of the slide, I have the Lewis structure for caffeine and the chemical formula, which is C8H10N4NO2. Again, according to NCBI, the effects of caffeine on the human body are usually physiological. Caffeine has a tendency to increase motor activity, which can cause more alertness, activity, and restlessness. It is also possible to overdose on caffeine, which may cause dizziness, confusion, and vomiting. And then because caffeine can have addictive properties, it is also possible to experience withdrawals. And these symptoms may be anxiety, headaches, irritability, drowsiness, and even tremors may occur. And then, according to Johns Hopkins Medicine, there are some nutritional facts and health benefits of coffee. For nutrition, coffee does not have any significant amounts of macronutrients, carbohydrates, and fats or proteins. It does, however, have some micronutrients such as niacin, potassium, and magnesium. And then coffee is about 95% water, and this usually helps contribute to the daily fluid balance. All of these nutrition facts, however, are true for black coffee, but the numbers and amounts of the macronutrients or micronutrients can be altered very easily with dressing up coffee, so that's with the addition of milks and creamers and sugars, etc. And then coffee does have some health benefits. There's a potential to live longer. Studies show that coffee drinkers are less likely to die from varying diseases. You're also less likely to develop certain diseases and cancer. Your body has the potential to produce glucose or process glucose better. And then your DNA has a chance to be stronger because dark roasts usually decrease the breakage of DNA strands. Why is the chemistry of coffee important? Knowing the chemistry of coffee is quite important for many people and businesses, such as industry, for oneself, and for the occupations of farmers, harvesters, transporters, processors, roasters, and baristas. For industry, it's very important knowing how the composition of coffee works and how to manipulate the components of the coffee. And this usually helps increase business, so mass production of more than one kind of coffee that has different components will usually bring in more consumers, and this is also good for the occupations that are previously listed, or the third bullet point, because knowing the different ways to alter components is very smart because it will bring in more customers, therefore allowing businesses or industries or occupations to thrive and flourish. And then it is also important for oneself to know the health benefits, because if someone is struggling with their health, it is very beneficial to understand how coffee works and what it can do for you. In conclusion, coffee's main characteristics can be easily manipulated through the simple process of roasting and harvesting. During the roasting process, beans usually undergo the Maillard reaction and caramelization, and lots of chemical reactions occur in those reactions. Coffee can also possess many compounds and components that can affect the composition's brew, one of them being caffeine, and this is an alkaloid, and that can have many physiological effects in the human body. Caffeine has many nutrition benefits, including prevention of life-threatening diseases, and then being able to understand how the brewing process of coffee can be very beneficial and important for many people and occupations. This is my Works Cited page. Thank you so much for listening, and have a wonderful evening.